Hello and welcome to second semester of Algebra 2. We're starting with polynomials and we're going to start with graphing them in factored form. So if you did the work that I assigned for the first half of the week, you should have kind of seen what happens with this stuff. So one thing, when you're doing the x-intercepts from factors, just like with quadratics, to find the x-intercepts, you just flip the sign. That's all you do to find the x-intercept. But something called the multiplicity affects what happens at the x-axis. So the multiplicity is like the exponent of the factor. So like whether, like if there's an exponent and what that exponent would be. So like, the first one would have a multiplicity of 1 because if there were an exponent there, it would be 1, right? So that factor only occurs one time. Sorry, my cat's making weird noises. Oh gosh. The next one has a multiplicity of 2 because it's squared. She does this sometimes. She's not going to throw up. She just makes weird. It's like a cough. Anyway, the third one obviously is a multiplicity of 3 because it's cubed, which means it's the same factor multiplied by itself 3 times. So as you should have seen in the activity, when you have a multiplicity of 1, what it does is it simply crosses the x-axis. So what I mean by that is just that, like, so you have this graph and wherever it is, it'll just cross over to the other side. So that part of the polynomial, like, it starts on one side of the x-axis and it crosses over to the other side of the x-axis. And it's just a very simple, like, for a multiplicity of 2, I call it a bounce. So that one, again, you've got your x-intercept wherever, depending on the number. And essentially it just comes up but bounces off of the x-axis. Okay, so it never actually goes to the other side. It stays on the same side of the x-axis. Okay. So the last one, I call it a zigzag. Okay. So oops. So if you have your polynomial and you have an x-intercept where it is to the third power, it's like it comes up and does a little zigzaggy thing, and then but it does go to the other side. So one thing that you should know is that if it's an odd number, if the multiplicity is odd, it will go to the other side of the x-axis. If the multiplicity is even, it will stay on the same side of the x-axis. It's just the more the bigger it gets, it all kind of gets condensed right there, like how this does the zigzag thing. That zigzag thing would just be more pronounced with like to the 5th or whatever. Anyway. All right. So end behavior, that's what happens at the two ends of the graphs. Okay, so that lets us know where we're coming from and where we're going to end up. So one of the things that we look at for end behavior is the degree. We're going to talk more about degree when we get into standard form, but right now, just know that the degree kind of tells us how many x's are all being multiplied together for the polynomial. So for degree, what you do is you add the exponents. Okay, that's how you find the degree. And then the leading coefficient is just in the very front. Is it positive or negative? So, and the degree can be even or odd. So when you have an even degree, that means that the end behavior goes in the same direction. So if it's positive, it's going to go up to the left and up to the right. If it's negative, it goes down to the left and down to the right. Okay. For odd, it goes in opposite directions, but the positive or negative part really focuses, think about that in terms of like where you end up, like on the, so like if it's positive, as you go from left to right, it's going to get higher. It'll start down low and it'll get higher because it's going to get more positive. If it's negative, it's going to start up high and then go lower because it's going to get more and more negative. But anyway, yeah, there you go. All right. So here's my example. So like I said, for degree, you're going to add the exponents, but the thing people generally forget is they forget to include the ones that don't have exponents. Technically, there'd be a 1 there. So I have 2 plus 1 is 3, plus 3 is 6, plus 1 is 7. So my degree is 7. And it is negative because there's, a negative in front. So if you go back up to our table, 7 is an odd number and it's negative. So the end behavior is starting up high and going down low. Now, this second part here with the what this actually means, this means that as x approaches negative infinity, so that means as x is going to the left, is y getting bigger or smaller. So you just go by your arrows. So the first one's the left. On the left, y is going to positive infinity. So as x approaches negative infinity, y approaches positive infinity. As x approaches positive infinity or goes to the right, y approaches negative infinity or goes down. So really, just if you can remember the arrows, you just make your infinities match your arrows. Positive is up, negative is down. Should make sense. Okay, so the roots are the x-intercepts. Now, what you want to do with each factor is you want to flip the sign. But if you have an x in the front, like I do, then that's just going to be 0. Okay, so I've got 0. And then based on the multiplicity, I'm going to go ahead and write off to myself that 0 is a bounce. Then I've got negative 3, which is to the first power, so that's just going to be a cross. Then I've got positive 2, which is to the third power, so that's going to be a zigzag. And then positive 4, which has a multiplicity of 1, so that's just a cross. So when I graph this, I'm going to put a dot at each of those numbers. I'm going to put a dot at 0, at negative 3, at 2, and then at 4. And then based on my end behavior, I'm going to put arrows. So if I have an up arrow, it's going to be at the top of the graph. And if I have a down arrow, it's going to be at the bottom of the graph. So if I do this right, I should start at the arrow to the left and then end up at the arrow at the bottom. Okay. So once you get the hang of this, it's really not bad. Okay, we're going to practice it, and I'm going to go over this again tomorrow in the live meet, but I wanted you guys to have a video to watch too. So I'm going to start at this arrow, and then at negative 3, it goes straight across. So once I get to that dot, I just go across to the other side. Okay. Now at 0, it's a bounce. So it does not matter how low down I go. We're not paying attention to that. The only thing I'm looking at is which direction your arrow is going and what's happening at the x-axis. Okay. So at some point, I turn back around. That part's unimportant. But at 0, I'm going to bounce, right? Because remember, bounce just stays on the same side. Then I at some point need to turn around and do a zigzag. So that means I'm going to kind of come up, flatten out on the x-axis, and then go to the other side. It should be relatively obvious that you're doing a zigzag, okay? And then last, I got to come back down and just go across at number 4 and end up at my other arrow. These graphs tend to look really weird like this. That's okay. Polynomials are kind of kooky looking. But anyway, that's what we're doing this week is this. So we're, like I said, at the live meet, I'm gonna go over the tables with you guys again, and then we are going to practice a few of these graphs. So anyway, that's it.